Welcome back. So in this video, we are going to go through the creation of the material that makes this highlight around a object of your choosing, basically. And this is what the material looks like. And what we're going to start with, though, is more of a pixel description of what we're doing. And so what I've done here is I've got this in Excel. I made it my own little graphy pixel thing. And this blue object with our magic 250 number in it, which is basically arbitrary, just has to be between 0 and 255, I think is your limit for those. It'll clamp out from that otherwise in the engine. So that's our custom depth value that we're using. You can use a bunch of different ones if you want different effects, but right now that's the only one we're dealing with. So the way it works is in the material, basically the material is responding to as the screen gets rendered every frame. It kind of starts up in the top corner with a U value of 0 and a V value of 0. And then U value slowly increases as we come across, and the V value slowly increases as we go down. Okay, so this is the positive direction of both of those moving. So as each screen position is getting drawn, what our material wants to do is it's interested in this thing because it wants to do something when it gets close to it. So when we get to, as we come along, as we get to this pixel, we want to, and we're now near this value on this object. And so the material is always looking, and let me just, I'll highlight this because this makes it kind of show up pretty good. Makes it always looking at these values around it. Okay, so no matter where it was, we're only looking at it near here because that's what's important to us. So when I'm in this pixel, let me just do that again without selecting. So when I'm in this pixel in the top left of our object, what our function is going to do is, what it does is it looks to the left and it looks to the right, and it gets a value, and it gets the difference between the value to the left and the value to the right. And then it looks above, or it looks below and above, and it makes the difference between above and below. Then it looks to the bottom right corner and the top right corner, and it gets that difference. And then it also gets the difference between the bottom left and the top left corner and gets that difference. And then it adds all that up. And if it gets a value that's equal to our custom depth number that we gave this object, then we'll make a screen highlight, right? So that evaluation that I did in here for that pixel resulted in 250. Okay, 250 is our magic number, and so 250 got a highlight, just some conditional formatting. Okay, so as we step across, so here in this one, we're looking again that difference from below and above, so that's 250. And then we did left right, that was 0. This one's 250, and then this corner is another 250, right? And so we added that together. So we added all those sums together, and we get a value of 500. Well, 500 is not our 250 magic number. And so what we'll do in our material graph is we'll clamp that value to be a maximum of our object. Yeah, that I'm just foreseeing that might be a goofy thing when if we got like 251 and a 250 both in the same one. No, it should still work because they'll be the same value. No, we're good. So the reason why it has to be a difference, so when we're here again, the reason why it has to be a difference is that we just want to highlight the edge. So when we're in the center, right? So you see down here, these are the values that come out to be zeros. And so the reason why is that if we're inside the object, right? So that's this position here. So we're completely inside the object. So now it's to the left is 250 minus 250, right? So that's 0. Top and bottom, 250 to 250, that's 0. Left's 0 to the right's 0. Okay, so then this one calculates out to be 0. Well, 0 doesn't get the highlight, is what we'll say, because it didn't it passed the clamp because it wasn't greater than 250, and so it became the 0 value. And since it didn't, it wasn't our custom depth number, we're just going to pass through the underlying image. And so that's the function, okay? And I'm debating whether I should just show you the whole function or if we should just build it again. But I think I might be lazy and just show you. Yeah, let's do that because it's simpler this way, and I can do more explanation and less clicking and dragging. So first off, you need to come in and create a new material. So to be able to do that, come into materials, right click and go new material. Okay. When you open that up, all you will have is this node here. This node here, you need to come down into the material domain and select post-process. Okay, because it'll start off as something different and I don't want to change it right now. Just because I don't want it to break anything. So basically then we only end up with an emissive color, and that's what we want to input into. So thinking about our spreadsheet here, our pixel graph that we created, one thing that I set here or determined here was a column width so that I could create a pixel and to be able to move left and right on that. And so there's called a texel size. So depending on the resolution of the person's monitor, whoever is watching and using this, right, this will get that value of that pixel size, more or less. Okay. And then we're going to multiply that, and I'm going to say it's a half thickness. The reason why I'm going to say it's a half thickness is if, again, we come back here, we'll see that when we are evaluating this pixel, right? So that's this value here. Our function, even though we're inside the object, we're right on the edge of the object. And our function says we want to highlight when we're near the edge of the object, right? And so we've evaluated here, and that is this value of 750, which gets clamps to 250, which then gives us our highlight. So our highlight is actually 1 pixel outside the object and 1 pixel inside the object. So our width is that we end up with, right, is 2 times whatever we multiply by the pixel size, right? So if we give it the half thickness, then we'll get a better number, right? We'll get more of what we're expecting. But the thing is that it's half outside and half inside. I tried to think of a way to get that to not work or to get it to only be on the outside, but my attempts only ended up shading up the whole inside as well. So I'm good with this. But if you guys figure out a way, post it in the comments. I'd be interested to find out. So that's all that this is doing. So we're just getting this. We're just getting the size of the pixel, and we're scaling it up so that we can see it a little better. So that's why we're multiplying it there. Now we're going to take, we're going to mask the R value. So this comes out as a 2D vector. And so the R and G components. So just make a component mask here. So just component mask. So it's just a component mask. And then you'll just need to uncheck the green value. And then you got a mask R value. Okay. And so that is a positive value, right? And then we're going to take a negative of that. And that's to the other side. So all that is, again, in here is when we're, say, here. So that is plus u, and this is minus u. And similarly, well, I'll do below later when we get there. So that's all that is. So this is where we're looking to the left and looking to the right. Now, these are a 2D vector with the x value being the value that we're interested in, right? Our u value. And so we need to be able to work with it. We need to append, since we took out the mask, that's right, we took out the mask. Now we want to put a 0 in on that. And that is just more or less a way to control so that we're only looking left and right off of our screen position. So our screen position is just the the engine looking at this pixel. So the screen position is saying, like it says, the screen position expression outputs the screen space position of the pixel currently being rendered, right? And so in here, we're interested in, I want to render this pixel. What and what do I want to do about that, right? So that's our screen position. Now we want to, we're looking left and right of that, right? So if I add the u, the value of u, I'm going to look to the right. If I subtract it, right, this was the -1, so if I add a negative, I'm looking to the left. So that's all that is. Oops, sorry. All that is I'm here, right? Let me just get the formula marks up. So that's looking to the right and looking to the left. Plus u minus u. That's these first two values. Then we go into this node here, which is a scene texture custom stencil. So that's, again, this node is going to basically return the value that we have input that we want, which is that 250, right? That's the value that we set in our template, our custom depth red, right? Which we set in our, oh dear, what have I got in here? I was hunting a lot about information about things here. If we go into our our source, where are we? Here in our template.h, we created that custom depth value and we set it to 250 here, right? And so this node is going to return that value that our custom stencil, that object, is basically sending out. And so that node is just going, when so this node has been given a UV coordinate. And so and that UV coordinate is this value here to the left, to the right of the pixel that we want to render. And so we say, hey, screen textured node, what's your value in this UV coordinate? And he comes back and says, well, I'm 250. And we go, awesome. So this value comes out as 250. And we're just putting a mask on it just to clarify or to confirm that we do only have that single value of the R value. And then similarly to the right. So this one, in that particular case, is come back and it's going to say, well, you're not on me, so I'm going to give you a 0. So it comes back and it gives you a 0. This distance node, think subtraction and absolute value together. So it's a absolute value, it's a distance, right? Don't have a lot of negative distances. And so that's in my formula. So that's my absolute value of hx minus f6. So that's these two, calculating out to that. So that's this. So then we do the same thing. So that was with the horizontal, right? And I'll hold it here for a second so that you can get a pause on the video if you need it. So that's our screen position. This was our appended vector moving left and moving to the right. So that's our right textile and our left textile. So to either side of our screen position. This one outputs our value of 250, or if that UV coordinate is in our object, and it gives a 0 if we're not in our object. And then we evaluate a difference between those two values. Okay. And then similarly, we do the V coordinate. So positive V is moving down your screen. Negative V is moving up the screen, right? So positive V, again, the same append and to the 0 vector. But this time, okay, so here's a difference, is in our component mask off of our screen texel, because this may be different, I guess, in positive and or in X and in Y. I guess so. Maybe. That doesn't sound right. Don't know why this. I'm going to just go along with it though. So, yeah, interesting. Um, so we're taking the green value. So this was the U value and this is the V value. I guess there could be some stretched screens, maybe. Maybe that accounts for that. And we're going to look at the up and the down of it. Similarly, so we're multiplying by the -1. And then we're appending, but now when we do that screen position, right, again, we want the V coordinate. So we're actually going to put a 0 as our first element in our array that we're going to create with this append value. and we're putting in our v value here into the second coordinate. And then we're going to add that to our screen position. So again, it's gonna bump us up the screen or down the screen, because this was positive, and positive moves us below. So this is our bottom textile. And this one was negative, so it moves us up 1 point on the screen. The same two nodes again, but now it's going to say, hey, are you on the object? I'm going to give you a 250. And if you're off the object, I'm going to give you a 0. We take the same first value that's coming out of that, and we do that difference. So exact same as before. And then these final two cases, which you can basically copy all of this part, I guess, the same. And then what you need to do is build it so that this appended vector has got a u. So we grab a positive u movement, and we're going to grab a positive v component, right? So that moved us to the bottom because we added positive v, and it moved us to the right because we added positive u. And then we're going to say, are we in the object or not? And then we did a positive u, so we moved to the right, and we did a minus v, so come off a minus v into here, and that'll be our top right. In other words, we're drawing to the bottom left. Yeah. And so those again, doing the exact same thing as before. And then similarly, we want to look to the left, so that's our minus u and v. So that's our bottom because we had positive v, and we're moving to the left, minus. And again, are we in the object or off the object? And then the final one is minus u minus v. So that is the top because it's minus v, and we're on the left because it's minus u. And then we create and again, we ask the screen depth stencil, are we on you or off you? So we do all of those same distance calculations, right? So that's those absolute values of the difference between the left and the right side. And then we add that all together, right? We add that all together. And we add that all together. And that's when we get that sum. So this is at the point we're here. So at this point, we've got this matrix of values. Well, to be fair, we're only calculating one of these values at a time, right? This whole function is calculated for every pixel on the screen as the screen gets scanned. And so that is the function that we are at this point. And that outputs this value, right? And so now we made this clamp. Here it's just a clamp. It's easy, right? Minimum 0, and the maximum is our custom depth value, which is a parameter. So if you want, you can just, if you hold down 1 and click the left click, you'll get a constant, right? And you can right click that, and you can say convert to parameter, and you can give it a name, right? That's going to be something that we'll probably attach in the future somewhere along the way. When I create a material instance of this, I'm thinking, so that we can have different values or different color schemes for different overlaps for different types of objects. So that's our custom depth value. And then we're going to also use that same value here. You can just copy and paste it here. And so now we've clamped it to 0 to 250. So in our spreadsheet, that's here. right? That's my minimum of the value, or 250, right? So that's just the clamp, getting rid of all those other multiple values when we're on the interior edge of the object, right? And so what does this if statement then? This if statement is now saying, with our incoming value, compare it to our custom depth value. And if this comparison is if our input value is greater than our B value. Oh, interesting. If it's greater than our B value, that would be, in our case, let's say we're coming in with 250. Is A greater? A is this, A is our input value. B is this value. And so if A equals B, so in other words, if our input, our clamped value, equals our B value, then we'll output, because that'll be a true statement, we'll output 250. And then if we're different, so in other words, if A is either greater than or less than B, right, with 0 being here, then we'll output this value, which will be 0. Okay, now we got something else. This is the occlusion down here, but let's not worry about that right now. So when we are on an object that wants to get highlighted, we will come through here with a value of 250. And we hit this if statement. And what's going on here? Well, there's this object here, the scene texture post-process input. So again, this is just a scene texture. You just type scene texture. Scene texture. It comes up with scene color, but you can come over to the side here and you can select post-process input 0. That's the same way, I guess I didn't explain that before over here at the other side, is to get your component mask one, or the, not custom depth. Custom depth is another one. I've just, the name of it kills me now. Custom stencil. So if I select this node and come here, there will be one called custom stencil, and I don't know why they're not alphabetical, but there's custom stencil, and there's that node that we had over there. Sorry about that. But post-process input 0 is what the screen sees before, or what the camera sees before any post-process effects, right? So in other words, this is the pure image. Here's our highlight color. You can set it to any color you want. Doesn't matter. This is where you would change that. So we're coming in here with a value of 250 because we are on an edge of our object, and we're going to say if A is greater than B, right? So we are coming in at 250. That's greater than B, which is in here set at 0. So what are we going to output? We're going to output the value. We're going to output this value. Because A is greater than B, we're going to output whatever we put into this pin. And so, and if A is equal to 0, right, because of clamping and or comparisons, if we come in as 0, well, that means if A equals B, so if these are both 0, we're going to give it the post-process input. In other words, the pure image. And if A is less than B, interesting, basically any other possible case, because it needs to be hooked up to something, because this if statement will yell at us if we if I disable this, it gives you an error. So we're basically every other case equal or less, we're going to just give us the image, and then you would just attach that to the emissive color. And that is the extent of the material. Now, this little part down here, which is interesting, is if when an object is in front of our interesting object that we want to highlight. And so I'm going to just disconnect this and apply it. It's just going to multiply by 1. In other words, no change. And let's go back and look. And if let me save and restart this. So we're highlighting, right? And we come over here and we're going to hide behind this other character a little bit. And I'm going to highlight that other guy. See, we just highlight right through him, right? And now if we reconnect our object, our line here, apply that, and go back here. Look at that, I didn't even have to restart the editor. It now doesn't, which is, to me, is an amazing bit of magic. And so what it's doing is it's looking at the depth of the objects in the screen. And what we're getting is the depth, the distance between the camera and this highlighted object, right? And the camera also can say, and any other object in front of it, basically. And it looks and says, as I'm trying to draw this pixel here, there's a thing behind it at a certain depth, and there's this thing at a certain depth. And if this thing back here, if that depth is bigger than this depth, then let's not draw that highlight. That's basically what this is going to do. So we get the depth, the distance from the camera of our custom depth pass, right? So remember, in our enemy character, if I look at our custom, under custom, we are rendering in the custom depth pass, right, with a value of 250, right? And so in that, our custom depth, this object that has a value of 250, how far is it from the camera? And then the scene depth of the kind of the first object in the way is a different object. So that was that other character that was in the way, or whatever was in the way. And so it has a distance from the camera. So taking that first value, again, I wish I knew a little bit more about what was coming out of this color node. I guess it's okay to just take that first red channel. And now we're going to subtract them. So if this is a bigger number than this, that means this is further away from the camera. And that means that this is partially covered. This is covered by this object, right? So it's positive if it's covered. We're just going to round that off out of any goofiness to the rounded up. And then we're going to clamp it between 0 and 1 so that we can have better control on our values, because what we really want is an on-off switch for that pixel. And so 0 being off and 1 being on. And since we want to, we want to force our highlight. Remember, up here, we were coming in with a 250. It's highlighted, right? But it's occluded. So if we can multiply that by a -1, right? If we multiply it by -1, now this will be minus 250. And now we'll get that negative value, right? So that makes sense now, right? So now if we're negative, it'll just draw the image, the pure image, without any highlight for that pixel. Because if this multiplies by 0, well, then we're going to get this would come through as 0, and A would not equal B. I guess it would. Huh. Interesting. But I don't think that works. I don't think that because we only get for us to get 0, we would I guess need to be at the same depth. And so that's the only time that you're going to get a 0. Because if this is negative, that means this guy was in front of us. If they're exactly at the same depth, right, we would get 0. It'd still be 0. We would get 0, and we would be drawing. We would draw the the unhighlighted image. So that's pretty fine. I don't think that would ever happen. But I think that's the conclusion of that material and how it works. I think it's a lot to process, and it took a lot of it takes a lot to appreciate how it's working. Like, this is one of my notes that I wrote as I was trying to understand it. I don't even know if this is a good understanding anymore, but so the UV input on the custom stencil is a query on the stencil. The value returned is the stencil ID on the mesh. Here we are getting an offset of our texel size and width and adding that to the current render screen position and inputting that UV location into the custom stencil. So we're looking at the mesh stencil from a screen position offset from the mesh. The custom stencil node then output its value if the UV on the mesh and this material then draws the highlight color at the current screen position. So the result is that the stencil is drawn at the current render screen position. So when we're looking plus V units away, we draw the stencil 0 units away from the current position, meaning above the actual mesh. Yeah, that's horrible. That's why I had to make this Excel spreadsheet, just to kind of say, I'm here, I'm I'm on this pixel, and now I'm just going to look at the pixels around me. If I find a 250, then I want to be shaded red. And then I'm at this pixel, and I'm going to look around me. If I find a 250, I want to shade red, right? And if I'm in here, and this is why you have to do the difference again, remember, I'm going to look around me. Well, I'm finding a lot of 250s. And you would think, well, I want to shade red, but it's like, no, 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 I don't want to shade at all because I'm inside. I'm well inside, as opposed to just on a perimeter. And that's why we end up with the half thickness, or the double wide highlight, if you want, because that edge condition is produced for 2 different pixels. And there might be a way to clean that a little bit more, but I kind of like this. It gives a nice highlight that's to both sides. And if I look at that again um, in our map, and if I just if I exit from here and If I, sorry, if I come in here and on here, if I just come down to render our custom depth, I just turn it on, that's a nice little highlight. And if we come here and increase that to say 5, so now we're going to get a 10 pixel wide highlight. If I look back here now, save that, you know, maybe that's something nice, but it's nice and crisp, right? Now it's always 10. So let's push play and see what that looks like. Oh, I mean, I'm gonna, I'm going to, oh no, that was fine. It just needed one swing. Anyways, let me go way over here. Well, I suppose that's okay. It's kind of wonky. I think that's obviously too big of a value, and maybe there should be some other distance requirement um, on the screen capture thing. But let's take this back down to something probably more appropriate, say 1.5. So if I was far away and my enemy, that's pretty good. You don't want it to be too jarring, right? You just want to be able to see that that's being highlighted. You're trying to shoot at them or something, or you're looking around for objects that you can pick up, right? Well, there's another thing that we'll fix is the camera collisions and stuff. We'll do that in a cleanup video, um, so that our camera doesn't try to jut in at certain points like that. At certain times we want it to do that, but not maybe not all the time. Okay, that's it for the explanation of the post-process highlight. Um, I hope that was a good description for you, and I think this was the 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 best understanding of all of it with that formula right there, and looking at those values around, and just again, just you could probably compare any which way you want, but keep it in order, left and right, up and down, and the corners and corners. And yeah, and you get the value. And what I did is I made a bigger one. Here's some bonus feature for you. And where I can fill in, and this is, now you got to remember how fine of grain of this is. This is basically, we're talking pixel by pixel here. So that 2 pixel wide object gets a 4 pixel wide highlight. And if we zero these out, you know, we start getting highlight in this is what would happen if it was only 1 pixel wide, is you would get the object, you would get an interior bit, because this is a donut, you get an interior bit of highlight and an exterior bit of highlight around your donut, right? And then let's see what happens if you do this. You know, the highlighting is going to be kind of wonky, but again, this is a whatever. This is a 9 by 9, 10 pixel object, so it's pretty small. The fact that it's doing anything is amazing. But yeah, so thanks a lot. I'd be surprised if anybody was still watching at this point, but have a great time. We'll be back onto the template with the next video, and we'll start hopefully getting into some of the gas setup shortly. have yourself a great day. And if you like it, and subscribe if you want to see some more. I don't put videos up very often, but it's only after I learned some stuff. Have a good day. Okay, so after a little bit of testing there, 'cause I figured there would be something amiss with our clamping situation here, and so I've modified it so that our value coming out of our summation, so nothing changed over here, um, and so that part was all fine. But after we come out of this second add, as we summed everything together, let's clamp it between 0 and 1. So it's either on or off. Okay. And then at that point, we can multiply in if we are hidden or not, right? So we can multiply that in. Sorry for this is crazy zooming. So we can multiply that in. And then what we want to be able to do is at this point here where we are setting whether we draw the with post-processing or not, right? So now we're doing basically a check here of 0 or 1. And so 1 is greater than 0. So that in that case, we are going to draw our highlight. And so to be able to have different highlight colors, we get our custom stencil node. Okay, so this is going to return our stencil value that we assign on an object, right? So in our case, we had 250. I've made another enemy that you'll see in a moment, and I gave him a value of 240. And so again, taking that first value out of that color array, and we compare it to our 250, right? And so if they are, in this case, this is my highest point on my waterfall, if you think of it that way. So if we're gonna start off, it's gonna be 250 because everything gets set to 250. So if this value comes in and it's 250, then we will get red. Red will come out of here. This value is coming in, it's still 250. 240, our incoming value is 250. So A is greater than B. So we're going to carry our red will pass through. And similarly here, we're going to compare it with 230 and red will pass through because our value dropping in, our A value that we were inputting is 250. 250 is greater than 230. So whatever was coming out of this one will continue. So our red will drop all the way through. If this value comes in and it's 240, so it comes in here, well, 240 coming in 240 is less than B, so it's going to set red, right? We have to just have this as a default to start. So red's coming through. Now we're coming in with our test value of 240. We're checking it against 240. Well, now they're equal. So A equals B, and now we're going to pick up blue. So blue's going to come out. So blue's coming out, and now we've got our 240s checking in with 230. Well, 240 is greater than 230, so our blue will pass through. And then we pass that up into our case when A is greater than B. So A being 1, in other words, we're on or off, right? And then we pass that into our emissive color. So now if I go back to our, I'll just compile that and then go to our workshop, you can see that we've got one here that's blue and one that's red. And if I look at this item here, And I manually have adjusted this to be custom depth path, so it's on, and it's set at 250, and this one is set at 240. So if I change this to 230, it should turn green, and it turns green. Similarly, this one. And if I change this to, I wonder, if I change this to 255, it stays red because that was our maximum, right? So when we came in greater than anything greater than 250, right? So maybe I should have a maximum at 256 or something like that that comes in as a no color or something, but I think that's okay. Again, these are values that you get to set while you're going anyway. So whatever your range is that you want it to be. So let me go back to this guy. And if I set him to 240, then he should turn blue, right? And then if they, oops, and if they hide behind each other, they're both selected right now, which won't generally happen. It could happen depending on your game logic. But what's kind of neat is that it actually drew around that half pixel thickness onto the green one and then the full one on the blue one with them both being selected. And the part that's hidden is hidden. So that's pretty neat. But if I push play and just do my mouse overs to clear them, because they're typically they're false to start, so they wouldn't be lit to start. But yeah, so now it turns green or it turns blue, turns green, turns blue, and they get hidden. Do 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 do. That's so cool, right? So that's great for that. And yeah, so that solves that problem with the strange color overlapping and really cleans this up a lot more. And so it's the one material, and we just create this waterfall with however many different highlight colors that you want to make, and with that last one being dropped into here. And the importance is that each one of these is always a smaller value as you connect that stream together. So I'll just hold this here for one more little bit that you can get a screen capture that or whatever, but that is basically to set the highlight color by the custom depth value. Yeah, perfect. And this makes a lot more sense too, to just clamp to 0 or 1 on or off. And good to go. Thanks a lot for watching, and have a great day.